want to talk about exponents. We know now, we know and have known that a to the first is a. That's 1a. When we have a to the second, it means we're multiplying by another a. A to the third, we're multiplying by a third a. And a to the fourth, we're multiplying by another a. And we could go on forever, but we know what that looks like. So let's go in the other direction. Let's see what we got. If we have a to the fourth and we want to go to a to the third, we know that we are dividing by a. We could also say we are multiplying by 1 over a. Remember that if you take 6 and you divide it by 2, it's the same as multiplying by 1/2. 1/2 of 6 is 3, and 6 divided by 2 is 3. So let's keep looking. So I'm going to go, if I go from a to the third to a to the second, I'm dividing by a. If I go from a to the second to a to the first, I'm dividing by a. Remember, always the same as times 1 over a or times 1 over a. Now, when the mathematicians were figuring this all out, it was a group of people, they all kind of thought about it and how it was going to go, and they wanted to make sure that they kept this process the same. Okay, same relationship. So now I have a to the 0 power. So what would a to the 0 power be? Well, if I keep this process here, I know that I'm dividing by a, right? I'm dividing by a, and a divided by a is 1. And so I want us to remember that, and you're writing this down as I'm writing it down, that any number to the 0 power is 1. Any number to the 0 power equals 0 power, okay, equals 1. That means that 4 to the 0 power is 1. 18 to the 0 power is 1. N to the 0 power is 1. So we want to remember that. Anything to the 0 power is 1, and it makes sense. I mean, you can see that in the line. So now we get to we know that there's negative numbers, and there's also negative exponents. Okay, so how about a to the negative 1? Well, we're going to follow our pattern here, and we're going to say this must be divided by a. Divided by a or times 1 over a. So a divided by a is 1 divided by a to the first power. There you go. Okay, and how about if we have a to the second power? Well, again, we're dividing by a. And so we notice that we're dividing by a. That's going to be 1 over a to the second power. That negative exponent is telling us to use the reciprocal of the whatever that number is. So you notice that a to the negative second is 1 over a to the second. And we could go one more place and say a to the negative third. And remember, I'm dividing by a, okay, or multiplying by 1 over a. I'm going to get 1 over a, right? That's the reciprocal. 1 over a is the same as, is the reciprocal of a, only now I'm using the positive exponent. So now we're going to write, and you're going to write with me, okay, that a negative exponent means the reciprocal of the positive. So let's let's look at a couple more examples here. I just want to make sense. Make sure you're sure. So 4 to the negative third power is the same as 1 over 4 to the third power. Notice 4, negative 4. And we've been talking a lot about reciprocals. We did a lot of work with reciprocals. Okay, if I have 6 to the negative second power, that's the same as the reciprocal, okay, only with a positive exponent. Now, also, I could say, what if I have 3/4 to the negative second power? Now, according to this process, it says I should use the reciprocal, and that's going to be 4/3 to the positive second power. Okay, and those are equal. That's what this equals this, right? So notice I'm using the reciprocal and making the power positive. Make sure, please, that you have all these notes.